Hello guys, welcome to the video. So in this video, we are going to discuss our question, Knight's Tour. Let's first understand our question. We are given an n cross n chessboard and we are given a row number and a column number that is a starting point of our knight. Okay, and what we have to do, we have to generate all the moves of a knight starting in the row and column that is provided to us such that knight visit all the cells of the board exactly once. Okay, we want to print all the configuration of the chessboard representing the route. Okay, perfect. Also, it is mentioned all the possible options in which a knight can move, total 8 options, and we have to give first precedence to r minus 2 and c plus 1 because a compiler is expecting output in such a manner clockwise. Okay, now let's see the input and output. So in this case, we have provided a 5 cross 5 matrix, and initially your knight is standing in the 0th column of the second row here. Okay, where 1 is mentioned. Here your knight is standing. So by that, let's also see the function that is provided to us. So function name is printKnightsTour. It is, we are also given the chessboard and represent number of rows and columns, and R and C represent where your knight is initially standing. In this case, it is initially standing here, second row, 0th column. Okay, and upcoming move. So every time your knight takes a move, you're gonna update your upcoming move. Okay, every time your knight takes a move, you're gonna update your upcoming move. And whenever your knight took all the moves, went to all the cells of the chessboard exactly once, you're gonna display the chessboard using the display function that is provided to us. So that's our question. Let's understand it better. Okay, so we are given a n cross n chessboard. I'll write here n cross n chessboard. Okay, I'm gonna write the row and column number 0, 1, 2, 3, 4, 0, 1, 2, 3, 4. Okay, also we are given a row number and column number where a knight is initially standing. Okay, so let it be anywhere, let it be here. Okay, so think of it like your knight is currently standing here. Okay, so this is your knight. Now we are given that there are total of 8 directions, in which your knight can travel. Okay, so what are those 8 directions? Let's see. If r first direction, we have to give first precedence to r minus 2 c plus 1. So it can be here r minus 2 c plus 1. What else? What else? Here r minus 1 and c plus 2. So here what else? C plus 2 r plus 1 r plus 2 c plus 1, right? R plus 2 c minus 1, column minus 2 and row plus 1, column minus 2 and row minus 1, row minus 2 and column minus 1. So these are the 8 directions in which your knight can travel. Okay, so these are the 8 directions. Now again, what your output is gonna be like, your output. So whenever your knight visit all the cells of the chessboard, right? Whenever that is the case, you are going to simply use the display function that is provided to us. Okay, that is already provided to us in the snippet, display chessboard function. Okay, now that we know this much, now let's talk about the 8 directions once more. Okay, so the 8 direction which your knight can travel. Okay, so let it be your any row and column in which you are currently standing. Okay, so the first direction, first precedence we have to give to r minus 2 and c plus 1. What else? R minus 1 and C plus 2. Right. What else? C plus 2 and R plus 1. Let's see more. R plus 2, C plus 1, R plus 2, C minus 1. Right. R plus 1 and C minus 2. C minus 2 and R minus 1. And the last one, R minus 2 and C minus 1. Okay, so these are the 8 directions in which your knight can move. Okay, so I will write here what is happening so that we can easily make the movement calls. Okay, so the first, we have to give first precedence to R minus 2 and column plus 1. Second, R minus 1 and column plus 2. Okay, column plus 2. Sorry. And the third, it is to R plus 1 and C plus 2. Let's see the other movements here. R minus 2 and C plus 1. What else? Fifth direction. So R, here it is R plus 2 because we are moving downwards, right? What else? R plus 2 and C minus 1. And the sixth direction, R plus 1 and C minus 2. The seventh direction, R minus 1 and C minus 2. Okay, and the last, the eighth direction. Okay, so here R will decrease by 2 and column will decrease by 2. So these are the total 8 direction that is allowed to you. Okay, I hope you get this much. Now what I want to show you is, let's see what I want to show you. Okay, so here is your knight is present. Okay, so this is your knight. Now if your knight, let's say your knight is here. Okay, so here it is a knight and you try to move the using the first move R minus 2 C plus 1. Of course, you know you will get out of the matrix. So for that you also got to handle some invalid cases. So let's talk about the invalid cases. What is the invalid? What is the invalid case? Okay, so behold, let's see the invalid cases. So if your knight gets out of the matrix, so that they all are invalid cases. Am I right? Think about it. If your knight get out of the matrix, then there is no point. So I can say if my row, if knight is somewhere where row is negative, so if row is less than 0 or column is negative, right? What else? If row is greater than equal to n, as you know, it's a n cross n matrix, and same for or column is greater than equal to n. What I mean here is, here we are, see, in the, try to remember the flood fill question. In the flood fill question, we took care of r is equal to n, and here we are using r is greater than equal to n. Why is that? In the flood fill question, we were only moving one step at a time, but here we are moving taking two step too, sometimes R plus 2, C plus 2, right? So when it is greater than equal to n, the row, and for column it is greater than equal to n, we will simply return. What else is invalid? So we know we are eligible to move in a same cell exactly once. So for that, can I say that if chess, the row and column in which we are currently standing is something other than 0. If it is something other than 0, that means we have already traveled it, right? So that's for the invalid case. Now let's try to code this much and understand it better. Okay. So I will full screen it. So first, let's talk about the directions. Okay, so how many directions we are allowed to move? Total 8 directions. Okay, so for that, I know you probably already got the idea. Total 8 calls is required. So first we have to give precedence to R minus 2 and C plus 1. And as you already know, every time whenever we take a move, we are going to increase our upcoming move by 1. Okay, before that, before taking any move, we are in here as we can see in the output. So in the row and column that is provided to us, we placed 1 in the main function. As you can see, upcoming move is initially 1. So the first step is going to be that in our chess RC, right, in the row and column that we are going to place our upcoming move. So that's perfectly right. Now, okay, let's complete talking about our 8 directions. So here we took care of 1 direction. What else? Second direction, third direction, fourth, fifth, sixth, seventh, eighth. Total 8 directions. Okay. So what other directions? So as we discussed here, column will increase by 2 and row will decrease by 1. What else? Column will increase by 2 and row will increase by 1. Okay, let's see it more. So if we increase row by 2 and increase column by 1, perfect. And if we increase row by 2, column by 1, what we are doing, we just discussed about these directions. Okay, so we are just simply calling the directions. Okay, r minus 2, so 6 direction, r plus 1, c minus 2. So r plus 1, and I will full screen it, right, and c minus 2. Okay, what else? R minus 1 this time and c minus 2, and the last direction, the 8 direction, r minus 2 and c minus 1. So these are the total 8 movements that is allowed to us. Now let's talk about the invalid movement. What is not allowed? As we discussed here, better invalid. If our row gets negative, column gets negative, if we get out of the matrix, right? So let's code it. If our row is less than 0, or our column is less than 0, or our row is greater than equal to n, all right, or column is greater than equal to n. So if we get out of the matrix, we are gonna simply return. Okay, now one more necessary condition, or we have already visited. So for that, if chess RC is something other than 0, if it is something other than 0, that means we have visited it, so we will simply return. Okay, so we took care of the invalid calls. Now let's talk when we will get our answer. Okay, so when our knight visit all the cells of the chessboard, as we have mentioned here, exactly once. So I say if upcoming move is equal to n cross n, so in that case I get my answer. So we are initialize upcoming move by 1. So if we place our knight, so let it be this is 1. If we take our knight is initially standing here, then it will get 2, 3. So if our upcoming move gets 25, right, so that means we have placed our knight everywhere, so we can simply display it. Perfect. So for that, answer, right, answer, if upcoming move is equal to n into n, that means we got our answer. We have traveled to all the cells safely. So I'm going to display it using the display board function that is provided to us, and then I'm going to return. So that is when I'll get my answer. Now I want to show you how it is exactly once, and our code is not completed yet. Okay, I will also show you that why. Okay, so first I'm gonna erase it, and yeah, give me a sec. Perfect. So let's take somewhere where your knight is initially standing. So let it be here. Okay, so in the second row, 0th column, your knight is currently standing. So you are gonna change its value to 1. Perfect, because of upcoming move. Now, total 8 directions is allowed to us, right? We are allowed to move total 8 directions. So how many choices will we have? How many choices will we have? First choice. First choice is going to be, can we move to direction 1? Can we move to a direction 1? If r minus 2 and c plus 1. Yes, absolutely, it is allowed. So I'll place, no, I'm not gonna place it here for that. Wait, I'll bring it. So yes, it is safe to place. So I will update upcoming move r minus 2 c plus 1 2. Okay, now we reached here. Now again, I will check for direction. For direction 1, is it allowed? Is it safe to place? No, it is invalid because our row will get negative, right? Same, now we'll check for direction 2. Is it valid? R minus 2 c plus 1. No, it is not valid. Again, our row will get negative. Now for direction 3. Is it valid? For direction 3, it is r plus 1 and c plus 2. And of course, absolutely, that is valid. Right, that is valid. So let me copy it once again. Right. So after direction 3 call, what is supposed to happen? Our row will increase by 1 and column will increase by 2. So row will increase by 1 and column increase by 2. So I'll place 3 here. So exactly that's how my recursion is working. I wanted to show it. And of course, we can have multiple paths, right? We have to explore multiple paths, and whenever there's no answer, we are gonna return. So for that, for example, you are somewhere, let it be, for example, you are here, and there is no movement that is allowed. So to explore more path, more option, you have to backtrack, you have to unmark it, right? You have to unmark your upcoming move. That's what we do when we backtrack. So here, after completing all the calls, I'm gonna unmark it. Okay. Chase RC equal to 0 because initially it's 0 everywhere. Now in the base case also. So first I'm gonna run it and then I will show you something. And if there is any if we get any error, we are gonna fix it. So I'll run it. Yeah, accepted. Yeah, perfect. Not accepted, I mean it's custom input. So I'm gonna show what the problem is with our output comparing to the original output. Okay. So I will open a notepad. Yeah, here is our notepad. So let's go to the top. I want you to find the difference. What is the difference between our output and the original output? Okay. So as you can probably see, in our output, instead of 25, we got 0. Here also, if we move downwards, right, again, instead of 25, we got 0. Because we are initially starting, let me show you. So we place our upcoming move initially 1. But whenever our upcoming move gets 25, we never place the value. We never place the value in our chessboard. So whenever we hit this condition, here also, if upcoming move equal to chess n into n, we have to place it. So chess RC equal to upcoming move. And of course, we also got to unmark it so that we can explore more options. So chess RC equal to 0. Now let's try running it. Perfect. So as you can notice, this time, instead of 0, it printed the output correctly. Right. Now let's submit it and see if this works or not. Perfect, 10 out of 10. So what we did in this question, We first talked about the movements in which our knight is allowed to move, such that so that we can visit all the cells via knight board in which our knight travel all the cells exactly once. And then we talked about the invalid base cases, right? And we got to also unmark it so that we can explore new paths. So this was our question. I hope you did understood it. If you liked it, do not forget to like, share, and comment. Thanks for watching.